All right, you guys ready to try some more? And everyone says, yes, we're ready. Okay, great, let's keep going. Okay, so same thing with this. We need to figure out what exponent we need to put on the 2 to make it a 1 over 8. So this one might be a little trickier for some people, especially if you don't know your powers or you're not really that great with exponents, just especially in your head. So let's just set it equal to x. And we'll turn it into exponential form just like we did for that example. So that would be 2 to the x is equal to 1 over 8. So if that was just an 8, like say it was 2 to the x is equal to 8, like that would be pretty easy. Then x would just equal 3. But it's 1 over 8. So it can't just be 3, because that gives me two different results. So how am I going to get this thing to turn into a fraction? Well, that's if your exponent happens to be negative. So x is going to equal a negative 3. So now that you've kind of got the idea, like, okay, if something's changing into a fraction or like a fraction changes into a whole number, your answer is going to have to be a negative. So for this one, what exponent does the 1/2 need to make it an 8? That's going to also have to be a negative 3. The 3 makes the 2 an 8, and the negative takes the reciprocal of the half and makes it an 8 over 1. All right, example G. What exponent does the 3 need to give you the square root of 3? Well, that would have to be a 1/2, since 3 to the half is equal to the square root of 3. So the radicals are going to involve some sort of a fraction. All right, example H, 9. What exponent do I need on the 9 to give me a 27? Let's kind of change that to exponential form, because that might not be too straightforward. Okay, so we can find a common base between the 9 and the 27. So 3 squared and 3 to the 3rd. So that would be 3 to the 2x equals 3 to the 3rd. And now that the bases are the same, they can drop out. So 2x is equal to 3, or x is equal to 3/2. Now, if you're really good at your exponents, some of you might be able to do this in your head, because it's kind of like, okay, well, what kind of a radical do I need? Like, you know that the 9 and the 27 have that base of 3. So it's like, okay, what exponent does the 9 need to get you to a 3? Well, that'd have to be a half. You have to square root it. And then you're going to end up cubing it to give you a 27. So that's exactly what this is. You square rooted it, the 2 in the denominator, and then you cubed it, the 3 on the top, to give you a 27. Okay, example I. What exponent does the 8 need to give you a 1? Well, that would have to be a 0, because 8 to the 0 equals 1. All right, let's look at this one. Log base 9 of 1. What exponent does the 9 need to give you a 1? Well, that would have to be a 0 again. Huh, well, that's interesting. You got 0 for both of those. So what do you think you're going to get for this one? Log base root 31 of 1. Yep, you guessed it. That's going to be a big old 0 again. So for this thing right here, log of base 189,745,632, you're going to have to raise that to a 0 exponent to give you a 1. So you notice the little pattern? Hope so. Anytime it's a 1 in there, that's going to give you a 0 no matter what that base number is. Okay, log base 6 of 6. That's going to equal 1 because 6 to the first equals 6. Okay, log base 6 of negative 36. What exponent, let's think about that. What exponent does the 6 need to give you a negative 36? And I have a lot of people go, negative 2. Well, 6 to the negative 2, that's 1 over 36. So having a negative exponent doesn't make the number negative, it just takes the reciprocal. So think about it. What number can you plug in for x that's going to make this, or this, turn out to be negative 36? There isn't one. So it's D and E. You can't plug a number into an exponent and have it come out as a negative. It just doesn't work. So that's going to be true for this. Log of negative 8. And this one, what exponent does the 7 need to be a 0? Well, again, you can't do that. You can't plug in a number into an exponent and have it come out as 0. Anytime you plug a number into an exponent, it should come out as a positive. Unless there's already a negative in front, that's the only time it can give you a negative. But it's not going to give you just a negative as a default or make it to 0. So if you've got a negative number in the log or a 0, that is going to be a D and E. It does not exist. Okay, this last line talks about the one log we haven't looked at yet, and that's the natural log. And it's the inverse of an E. So if you have an ln and an E together, they're inverses. So when you have an inverse and its function plugged into each other, they cancel each other out. Well, if they cancel each other out, what the heck is left? Well, what's left over is your exponent that was on the E. So ln of E is just 1. ln of E to the 4th is just 4. Now you can only cancel them when it looks like this or this, like ln of E to the something. E can't be in a fraction, it can't be in a radical. If it is, you gotta manipulate it. So 1 over E is the same thing as E to the negative first. Now they can cancel. The 8th root of 1 over E to the 7th is E to the negative 7 over 8. The exponent on the E is the numerator. The type of radical, that's the denominator. So that gives us negative 7/8. Okay, let's go ahead and pause here. And then we'll get into the graphs of the logarithms.